Video for class 6, and this is sample problem 3.4. What we're doing here is we're finding the equivalent moments using the concepts that we've used previously for three-dimensional things, but now we're going to use the cross product in a fully 3D problem. All right, so recall that this is not the reactions. We want to find the moment about A that's due to this tension that's in the wire that goes between C and D. So this rectangular plate is supported by it, and somehow we know what the tension is. We would just want to know for only the tension, only the moment that's around A because of the tension. There could be other moments, by the way, about A, including like the weight of the plate would create a moment about A. But here, we're just trying to isolate and identify the equivalent moment, you might say, of this tension. So the first thing that we're going to do is we want to find the force FCD on C. All right, so we're going to do something very similar to what we've done previously, and find. Well, first, let's do it in the terminology that we've been just introduced. We'll take R. It should be D with respect to C. Okay, so that's going to be this length right here. Right, it's going to be this point D with respect to C. And just from observation, we can see, if of course we have to choose axes, that's X, this is Y, and this is Z, we could see that we have to move in the negative X direction 300, right? So I'm going to keep them as millimeters here because it's going to work out anyway. So that's 300, negative 300 I, right? And then we take a look, and we have to go upwards 240, right? So that's 240. Remember, the concept is where this is D with respect to C. So we're starting at C, we're going to D, so we're definitely going upwards, so it's definitely positive. And then lastly, we want to go in the Z direction, right? But notice that we're traveling in the negative Z direction to get over to D, and it's going to be 80 plus 240, so it's negative 320, and that's K. And of course, we would add millimeters into there. Changing colors for no apparent reason. Okay, so what we would want to be able to and get the force in there, we need the magnitude. So let's get RD with respect to C. The magnitude is the sum of the squares of these. So 300 squared plus 240 squared plus 320 squared. And we get a length of 500. Works out nicely. So if we want FCD, what we're going to do is we're going to take the magnitude of, the magnitude of the force is 200. And so we're going to take a negative 300 divided by 500, right? And that's going to be I. Then we're going to have the magnitude of 200, and we're going to take 240 divided by 500, J, and then lastly the magnitude of 200 times the negative 320 over 500, and that'd be K. And these are newtons. Almost looks like kilonewton, doesn't it, too? Because I tried to squeeze it in there. There, put a big N. All right, so now we want to find the position vector of C, A with respect to C, right? Because we're doing it about A, C with respect to A, yes, okay? Because this is the reference point, and that's where we're going to, right there. So the R is going to be C with respect to A. And just from observation, we can see that we're going to go 300 in the positive X direction, and we're going to go 0 in the, because on y direction, because we're in the same plane, and then we're also going to go a positive 80 in the z direction. And truth be told, we should probably at some point change these into meters, because we don't want to have Newton millimeters, we'd like Newton meters. So the equation to answer the problem looks like this right here. We take the cross product of RC with respect to A and cross it against FCD. And it's going to look like I, J, K, and then 3, well, no, let's go with 0.3. And I'll put the other 0 zeros in there. 0, and then 0.08. 00. Extra suffix in there. And then, okay, so I didn't actually get this value down here. Silly me. I just skipped right over it. Negative 120 I, not a very good looking I, plus 96 J plus negative 128 K. And that's newtons. Okay, so here is a negative 120. Here it's 96. And here is a negative 128. And we want to take the determinant of that. So we'll do that. And we take, first off, I like to do this right here. I'll just take a look at that right there, right? So the determinant of this crosswise is 0 times negative 128.0 right? Minus, and we're going to go 0.080 times 96. Well, let me close it up with the right color. Plus, and I'm going to switch to some other colors going right here. I'm going to have this one and this one. All right. So that's going to be 0.3 crossed with negative 128.0 minus and 0.0800 times our negative 120.0. And I'll close it up with the correct color again. And that's going to be J. And are we going to be able to fit this all in here? I don't know. Let's go with baby blue. And so now we take a look at this, and we put together that cross product, or that determinant, excuse me. So we go 0.300 times our 96 minus 0 times negative 120. And going color coded for no very apparent reason. Boom. So we do all that mathy math and we put it all in there. We get a negative 7.68 I plus a 28.8 J, and then plus a 28.8 K. And these are Newton meters. Box it all up. And once again, just want to emphasize, this is what we're doing here is to find the moment about A of the force exerted by the wire, which is another way to say it's an equivalent moment. What is the equivalent moment of those? And so we are done. One last video. Discard. And the time is less than 10 minutes. I'm pretty happy with that.